Alright, we're sketching a curve. Problems 26 and 27 are curve sketches. And this is a mixture of algebra and trig, which means it's usually kind of difficult. But it is still, it's not a too powerful algebra equation. 2x, just 2x. And sine x is just going to be warped around the line. 2x. So we'll just give it a go. We're not asked to identify too many stuff, just identify the critical points, which will probably be our max and mins. And that'll be enough. Okay, so let's take the first derivative. This will identify the critical points. So that'll be 2 minus derivative of sine is cosine. The 4 comes for the ride. Set this equal to 0. And that's going to give us negative 4 cosine x equals negative 2. So cosine x equals a half. So when is cosine equal to a half? Now we're limited to the interval 0 to 2 pi. And there is no coefficient of x. So I don't have to do the whole add 2k pi thing. Okay? Because if I add any multiple of 2 pi, that's going to take us out of this region. Okay? And the reason why I mentioned there's no coefficient of x, if I were to have a 2 in front of it, then the whole angle will get divided by 2. So you might, adding 2 pi, you actually only end up adding pi if there was a 2 in front of this x, right? So that's why I mentioned the fact that there is no coefficient. It's in the interval 0 to 2 pi. So I only have to solve for the normal answers, the normal unit circle answers, okay, from 0 to 2 pi. Alright, so where is cosine positive, first of all? Cosine x is positive in the first and fourth quadrant. Oops, I can't write 4. Alright, 1, 2, 3, 4. Cosine is positive here, okay? Side note, all the trig functions are positive in the first quadrant. Only sine is positive in the second quadrant, meaning cosine and tangent are negative. And when we say all, we're talking about the triple, the sine, cosine, tangent. All right. And quadrant 3, only tangent is positive, meaning sine and cosine are negative. And in the fourth quadrant, only cosine is positive. That means tangent and sine are negative in that quadrant. That's just a side note. It's not completely required to solve this problem, other than knowing that cosine is positive down here and up here. Alright, so that said, what are the angles that's going to give us a cosine of positive 1/2? Okay, that's going to be pi over 6 is sine, so it's going to be pi over 3. That's going to be in the first quadrant. In the fourth quadrant rather, is going to be, it's just shy of 2 pi. Right, 6 pi over 3 is 2 pi, so it's going to be 5 pi over 3. Okay. Alright, so those are critical values. Let's make a sine chart real quick. So pi over 3 and 5 pi over 3. I know that doesn't look like a 3. Okay, so and we can't use 0, and we don't want to use 2 pi because that's out of our range. So let's pick a number between 0 and pi over 3. Pi over 6 is good. And what are we going to do with this? We're going to stick this into the derivative to see whether it's positive or negative there. So we plug in pi over 6 into 2 minus 4 cosine x. What do you get? That's going to be 2 minus 4 pi over 6. Oops, that's not. It's cosine of pi over 6, not just pi over 6. Alright, cosine of pi over 6 is root 3 over 2. So that's that. So the 2's cancel, so 2 minus 2 root 3. Alright, so 2 root 3 is going to be a little bit bigger than 2, so it's going to be negative. Okay, and then here, between pi over 3 and 5 pi over 3, 0 is a good option. So we're going to plug in 0 into 2 minus 4 cosine of 0. Cosine of 0, I said 0. Why did I say 0? Pi. Sorry about that. I am so sorry. That was a really bad mistake. Alright, anyway, pi. Pi is between pi over 3 and 5 pi over 3. So it's cosine of pi. And cosine of pi is negative 1, so it's 2 minus 4 times negative 1. So it's 2 plus 4, making it positive 6, so it's positive. And this is sine, right? There's no function of sine. It's very well behaved. It's going to go decreasing, increasing, decreasing. But let's double check. What is, okay, 5 pi over 3. Let's do it in terms of 6. Denominator 6, that's going to be 10 pi over 6. So another number in here is 11 pi over 6. Okay. 11 pi over 6, plug that in. That's going to be 2 minus 4 times the cosine of 11 pi over 6. And what is that? What's cosine 11 pi over 6? It's cosine positive, and it's going to be the same as it was last time with pi over 6. So it's square root of 3 over 2. So in fact, the expression is identical, so it's going to be negative in this region. So it's decreasing, then increasing, then decreasing. Alright, so the critical values are x equals pi over 3, 5 pi over 3, and that's for the actual point. So that means we need the y value. So to get the y value, don't forget, you need to go back to the original equation, the original function rather. So we're going to plug in pi over 3 into that. So what is f of pi over 3? And hopefully it won't take me too long. I don't feel like editing videos today. Whatever that is. Alright. 2 pi over 3 minus 4 times the sine of pi over 3. That's root 3 over 2. So it's 2 pi thirds minus 2 root 3. Now normally that's adequate, but we're graphing this, so I want a decimal approximation so I have something to plot. So I'm going to put this in the calculator. 1.369. 1.369. Okay. Alright, continuing. Negative 1.369. And let's do the other one. F of 5 pi over 3. That's going to be 2 times 5 pi over 3, making it 10 pi over 3, minus 4 times the sine of 5 pi over 3. 10 pi thirds. This is getting too long. Sine of 5 pi over 3. This time, remember this whole thing I told you earlier? 5 pi over 3 is down here, and sine is negative, so it's negative of that version. So it's 4 times negative root 3 over 2. So I don't know why I wrote a plus sign. The 2's cancel, and the minuses become plus, and it's plus 2 root 3. 13.94. Alright. That should be consistent. Let's use the same number. Although, you know, I'm not going to graph that to the nearest 10 hundredths thousand. So probably 13.9 or maybe even 14. Okay. So what does that look like? That's what looks really nasty. Alright, we've already established that it's decreasing, then increasing, then decreasing. What happens when you plug in 0? If you plug in 0, I get 0 minus 0. So it's 0, 0. Alright. So let's graph that. And through the magic of Desmos. Alright, can you see that? Oh no, it's not very dark, is it? Alright, let's try that. Alright. Alright, let's look at our values. Our values, there was one at pi over 3, and we got negative 1.369. So well, here's negative 2. So negative 1 is about there. Negative 1.3 we're going to make is about there. And remember, it was 0 at x equals 0. And then at 5 pi over 3, that's going to be our next max. 5 pi over 3, our next critical value rather, which happens to be a max. The y value was almost 14, so way up here. Let's put it up there. So, remember, this has a sine wave in it. So somewhere in between here, there's a point of inflection. We want to eyeball it. We could solve for it, I guess. The chances of me doing this correctly, I mean, like doing it without screwing up the drawing, is slim to none. So just be patient and be forgiving when I draw this. And the distance between these 2 points are pretty long, and I think I've already messed it up. I promise I'll be forgiving when I grade yours. Alright, and that's about it. Wow, that's not very pretty, nor is it very interesting. And this video is way too long.